All right, party people. So here we go. So this demonstration is a demonstration of atmospheric pressure. Okay, what we're going to try to do is, Emma is nicely in the bag. Okay, she definitely volunteered for this like 2 weeks ago, and she reminded me every day since then, so how could I forget? All right, so this is a shorter demonstration because she got a new haircut. But the point is, I might do it on my knees. Okay, actually to get in the video, I might have to. Now, the point is this, all right? Right now, in the bag, as we see Emma, there is scant pressure. Pressure is a force over an area. So the force over an area is the same inside the bag, pushing outward, as there is outside the bag, pushing inward. So the bag is just sitting there comfortably like Emma is. But we're going to make her uncomfortable once I zoom in. No. Once I take as much air out as I possibly can. So this becomes a shrink-wrapped student demonstration because what I'm going to do is take air molecules as much as possible out of the bag, which means the force per area is going to drop. You take N out, lower N, PV equals nRT, pressure is going to drop. The outside air pressure is going to dominate and push into her body and shrink wrap her. Now, if I was to create a perfect vacuum, which is going to be impossible, but if I get pretty close to that, the pressure she's going to feel, because there's no pressure pushing back, she's going to feel a second atmospheric pressure. Now, she doesn't really feel one atmosphere pressure. No one does because we've been what? Selected to live under this standard pressure. No one thinks about 14.7 pounds per square inch on her skin until you take it away. Okay? And if you've ever seen some of the movies where, you know, like Arnold Schwarzenegger, I think in Total Recall, it's an older movie, you guys are getting young, but they get jumped into a Mars atmosphere and they start blowing up, and because their internal air pressure is greater on the outside, you would expand. Okay? How much so, it's hard to say. It's never been done. Another demonstration for another video of another day. But the point is, we'll try this one today. So I'm going to pull out most of the air pressure in the bag. And so what's happening is because there's not an opposing force over an area, remember it's force over an area, she's going to feel an additional atmospheric pressure as if she was 33 feet, okay, below sea level underwater. Another 33 feet, you feel a second. So she's going to feel 2 atmospheres of pressure, okay? And what she's going to feel really is that additional atmospheric pressure because no one really thinks about the 1 atmosphere pressure that you're under. Okay, so if you think about what that additional force would feel like, okay, that's what she's going to witness. So if you think about atmospheres of pressure is 760 millimeters of mercury supports the mercury up at sea level. But another example of that is 14, or another equivalent of that is 14.7 okay, pounds per square inch. So every square inch on her body, okay, on the bag, she's going to feel 14.7 pounds. So she should be immobilized. Now we're not going to put her totally in the bag. She's going to be able to breathe. But wherever the bag fits, she should not be able to move, and we'll see that. Okay? All right, so enough talking. I did enough because people think I'm an old fart in these videos. Just do it. All right? So we're going to cover Emma. I'm going to scooch up there. Okay, scooch, scooch, scooch. More. Yeah, okay. Now, she's about as uncomfortable as she wants to be. All right. Of course, this is student A. I can't mention Emma's name on this. All right. Or what address and phone number. Okay, no, just kidding. So now what we're going to do is we do not want, okay, oops, excuse me. All right. We do not want the bag to stop this. So this draws air in because this being a vacuum, it creates a partial vacuum. And here it's drawing air in. This does not suck at all, right? Neither does demo, hopefully. But the point is I'm going to draw air out. And I do not want the bag inside to get stopped because if that happens, if this tube, okay, gets stopped, it stops drawing in air. So I want Emma to kind of cross her arms, hope to live, okay, and keep this opening free. Okay, so I want you to cross your arms and try to keep this from hitting the bag, okay, as much as possible. Okay, and then just make sure that this is working. Oh! It's okay. I'm okay. You guys are so worried about me. Okay. All right. So make sure, because if it's like this, and you cross your arms, and this gets stuck into the, it's not going to work as well. We want you to be shrink wrapped. Okay. Okay, we'll do this first with our head out of the bag, and then second with the inside the bag. Just kidding. Okay, so this nice and tight. You're ready to go, Emma? Okay. Sure. All right. Let's get this started. So here we go. I'm going to turn this on. Oh, yeah. She's shrink wrapped. Now, you feel that, don't you? It's totally immobilized. Get up. We're going to leave it like that. 14.7 pounds per square inch. Okay, so there I can pretty much all tip her over and she can't do anything. Thanks, Emma.